The next point, we should ensure whatever we see is clear.
That means work is being done, we can see that it is in opposite direction.
Hello learners, welcome to the geography class. I am your geography teacher, Wizzy Jeremiah Akos. We're here to treat the topic Earth's movement. Earth's movement. During the course of our lesson, we'll be looking at the types of Earth's movement. We'll be looking at the rotation of the Earth. We'll also be looking at the effects of the rotation of the Earth. We'll also look at revolution of the Earth, as well as the effects of the revolution of the Earth. We say that the sun rises in the east and sets in the west. This statement is true, but it gives the impression that the sun moves. The sun does not move. Now, what do we mean when we say that the sun does not move? We said during the course of our studies in primary school, that is in basic science, our teachers taught us about the solar system. And we're taught that the planets move around the sun. And one of the planets that move around the sun is the Earth. The Earth is constantly in motion. That is, it is always moving. Now, the Earth moves in two ways. What are these movements? We have rotation and revolution. Rotation and revolution. What is rotation? Rotation is the movement of the Earth round the sun on its axis. Rotation is the movement of the Earth round the sun on its axis. The Earth rotates on its axis from west to east. It is inclined at an angle of 23.5 degrees along its axis, and it takes the Earth 24 hours to complete one rotation. A simple example of rotation is when you look at ballet dancers. That is when the male and the female are dancing, and then he spins her around, and she stands on one point and turns around. That is rotation. What are the effects of rotation? Number one, we have day and night. As the Earth rotates around the stationary sun, only one portion of the Earth's surface, that is the part facing the sun, receives the rays of the sun and experiences daylight, while the other part that it's not receiving the rays is facing night or darkness. If you're able to see the diagram, you will see that the part that is facing the sun is bright, while the other part that is not facing the sun is dark. The second effect of the rotation of the Earth is the deflection of winds and ocean currents. We said the rotation of the Earth causes winds and ocean currents to be deflected to the right of the direction of their movement in the northern hemisphere, and to the left of this direction in the southern hemisphere. If you remember from our previous lessons on latitude and longitude, we said the Earth is divided into two parts. We talked about the northern hemisphere and the southern hemisphere. So when we mention hemisphere, this is what we're referring to. Number three, apparent sunrise and sunset. So apparent sunrise and sunset. During rotation, the part of the Earth that emerges from the darkness into the rays of the sun is sunrise, while the part that is moving away from sunlight into darkness is sunset. So sunrise normally occurs in the morning hours, while sunset occurs in the evening hours. Number four, we have time difference from place to place. if you're opportune to have people that have traveled to other parts of the world, let's say as we're here in Nigeria, you have people in Europe and in Asia, and you talk to them on phone, you have to synchronize your time to call them at the appropriate time. The reason is because of the time difference as a result of rotation. We said the Earth rotates through 360 degrees in every 24 hours. What this means is that we have said that the Earth is a droid. Now we know that the droid, which is like a circle, has an angle of 360 degrees. And a day takes 24 hours. No, so when you divide 360 degrees with 24 hours, you will find out that for every 15 degrees is 1 hour. This thereby creates time difference depending on where you are located on the Earth. Number 5, we have dawn and twilight. Dawn refers to the brief period between sunrise and full daylight, while twilight refers to the brief period between sunset and complete darkness. When you wake up early in the morning before the sun comes up, you go out, you find out that the place is bright, but you cannot see the sun. That is dawn. Or you're outside in the evening before the place gets dark. The sun has gone down. That means you cannot see the sun, but the place is still bright. That is what we call twilight. So rotation causes dawn and twilight. 6, we have daily rising and falling of the tides. So rotation of the Earth causes rising and falling in the level of water in the seas and oceans. It causes oscillation on the surface of the water, resulting in the rising and falling of the level of water in the seas and ocean. What this means is, a good example is when you go to fetch water in a container, preferably a pail or a bucket. When you pick it and you're going, the water starts to move from one direction to the other. That is what we refer to as oscillation. Now, if you're opportune to go to maybe the bar beach, that's ocean or the sea, or even the rivers, you notice that the water keeps on coming to the shore and going backwards. This is the oscillation that we're talking about that occurs as a result of rotation. Now, we look at the second movement, which is revolution. What is revolution? Revolution is the movement of the Earth around the sun on its orbit. Remember, rotation is when the Earth moves on its axis, while revolution is when the Earth moves on its orbit. Revolution of the Earth happens when the revolving Earth is tilted or inclined at an angle of 66.5 degrees to the plane of the ecliptic. Now, when we say ecliptic, we're referring to the plane on which the Earth orbits around the sun. That is, to put it in a simple way, we'll say the route that the Earth follows as it goes round the sun. That is what we call the ecliptic. So, the Earth is tilted at an angle of 66.5 degrees on the ecliptic. What then are the effects of the revolution of the Earth? We said the Earth revolution determines a year. When we say revolution determines a year, we're calculating the time it takes the Earth to move from point A and go around the sun and come back to that point A. And in our calendar, that is what we call 1 year. According to calculations, it takes the Earth 365.25 or 365 1/4 days to make one revolution. Now, we cannot put 365 1/4 days on our calendar. Therefore, we have 365 days for 1 year, and then we have a leap year. If you remember, a leap year comes once every 4 years. That is because this 2.25 days, which is the same thing as 6 hours, when you add it up times 4, it gives you a full day. So we add it up to the 4th year, giving us a leap year with 366 days. Number 2, varying lengths of day and night at different times of the year. Now, we look at this, the common thing we say is we have longer days, shorter nights. These are common things that we say, but we don't really understand what it means. This is what happens. The earth moves around the sun. To make our study easier, we look at it from 4 points. We have from March, and then we give a space of 3 months. We have June, September, December, and back to March, completing one revolution. During the time that it is in March and September, that's March 21st and September 23rd, we have what we call equinox. Okay, during that time, the sun is overhead at the equator. So there's 12 hours of daylight and 12 hours of darkness at that particular period. But during December 22nd and December 22nd and June 22nd, we have what we call solstice. We have 2 types of solstice, the winter solstice and the summer solstice. That is because the sun is either overhead at the Tropic of Cancer or at the Tropic of Capricorn. Let's look at further explanation. We said in the northern hemisphere, during winter, around December 22nd, as we go northwards, the hours of darkness increases. At the Arctic Circle, which is at 66.5 degrees north, the sun never rises and there is darkness for the whole day. That is at December 22nd. What that means is Nigeria is on the northern hemisphere. During December 22nd, the sun is overhead at the Tropic of Capricorn, which is on the southern hemisphere. So on the northern hemisphere, we experience darkness. But in the northern hemisphere, during June 22nd, the sun is overhead at the Tropic of Cancer, which is in the northern hemisphere, so we experience longer days. Now, this is a diagram showing us the 2 different types of solstice, the winter solstice and the summer solstice. Sometimes, depending on which book you're using or what reference you're following, they might give you contradicting dates. You might have December 21st or 22nd. The same thing with June. Some people will tell you June 21st to 23rd, depending on which calendar you're using. But when you look at the diagram for the winter solstice and the summer solstice, you will notice that the times are different. Like in the Arctic Circle, during the winter solstice, you have 24 hours of darkness at 66.5 degrees north, and you have 10.5 hours of darkness at 23.5 degrees south. While at the equator, you have 12 hours of darkness. During the summer solstice, it is different. At the Arctic Circle, you have 24 hours of daylight. And at the Antarctic Circle, you have 0 hours of daylight. Antarctic Circle meaning 90 degrees south at the bottom. So these are time differences that occur because of the position or the location of the Earth during the time of revolution. Number 3, we said it causes season. In the tropical areas like West Africa, we have 2 primary seasons, the rainy season and the dry season. While in temperate regions, they have 4 seasons. They have winter, summer, autumn, and spring. And then number 4, we have changes in the altitude of the midday sun. As a result of the Earth's revolution, the altitude of the midday sun changes, resulting in equinox and solstice. That's what we were talking about earlier. We said that the sun is overhead at the Tropic of Cancer, the Tropic of Capricorn, and the equator. However, the sun is overhead at the equator twice a year, while it is overhead at the Tropic of Cancer once a year, and at the Tropic of Capricorn once a year. So this leads us to have 2 equinoxes, 2 solstices. Now, what is the solstice? We said this is when the sun is vertically overhead at the Tropic of Cancer, which is 23.5 degrees north, or at the Tropic of Capricorn, which is 23.5 degrees south. Now, the Tropic of Cancer, the solstice, they occur in December 22nd or June 21st. These are confirmed dates. If they ask you for exact dates, you use this particular date, December 22nd or June 21st. The tropics mark the limit of the overhead sun. Outside these 2 points, the sun is never overhead at any time of the year. Now, to give you a simple example of what overhead means, during this time that the sun is overhead, you stand, when you stand and let's say 12 noon, you find out that you are standing exactly on your shadow. That is what we mean. So the sun does not, if you look at the picture of the globe, the sun does not go outside the Tropic of, it's never outside the Tropic of Cancer or the Tropic of Capricorn. That is its limit. In winter solstice, that is when the sun is overhead at the Tropic of Capricorn, while the summer solstice is when the sun is overhead at the Tropic of Cancer. We've said it, we'll say it again so that it remains in your head. Now, these are also the diagrams of the solstice, like we've discussed. We'll continue. Equinox. What then is equinox? We said this is the time when the midday sun is directly overhead at the equator, 0 degrees. They occur on March 21st and September 23rd. Note the dates, March 21st and September 23rd. Equinox is from the word equal. It means equal day and equal night. That is 12 hours of daylight, 12 hours of darkness. Spring equinox occurs in March 21st, while autumn equinox occurs on September 23rd. This is a diagram of equinox. If you look at it, we have 12 hours of daylight and 12 hours of darkness on the entire globe. September 23rd, March 21st. Next, we have number 5, which is changes in the seasonal temperature. It is observed that summers are usually warm and bright, while winters are cold and dark in the Arctic region. During summer, the zenith of the angle of the sun is higher. The concentration of heat over a small area leads to high temperatures. Days are longer than nights in summer, while winter nights are longer. It still explains the longer days and shorter nights. However, we're referring to the temperature or the hotness or coldness of a place at a particular period of time. We said in winter, the oblique rays of the sun fall faintly over a large area. Winter referring to the cold period. The little heat makes the temperature to remain low. 20 hours of daylight in summer and 20 hours of darkness in winter. That is that. And then we said days are longer than nights in summer, while winter nights are longer. To make it easier, we'll say when it is cold, our nights are longer. When it is hot, our days are longer. Commonly here in Nigeria, you find that our nights are longer around the December period, around the Christmas period, the holiday period. So it helps us to remember that around the December period, we're experiencing solstice. Now, we'll look at an eclipse. We've heard of eclipse over the past few years. What is an eclipse? We said an eclipse is formed when 3 bodies, particularly the sun, the earth, and the moon, are in a straight line during the movement of the earth. The moon revolves around the earth once in 28 days, and the earth and the moon travel together, making a complete movement around the sun once in a year. That is, as the moon goes around the earth is going around the sun. During the course of this movement, they form a straight line, and this line leads to us to have what we call eclipse. There are 2 types of eclipse. We have the eclipse of the sun and the eclipse of the moon. Eclipse of the sun or solar eclipse is when the moon comes in between the sun and the earth, thereby causing the moon to cast its shadow on the earth. Now, this solar eclipse is of three types. We have three types of solar eclipse. We have the total eclipse. That is when the moon is able to cast its shadow on the whole earth. And then we have the annular eclipse. It's when the moon is able to cast a shadow in the middle part of the earth. And we have the partial eclipse. It's when the moon casts a partial shadow on the earth. Remember, when the moon casts its shadow, we're having a solar eclipse. That means the moon is preventing the earth from getting the rays of the sun. Then we have the lunar eclipse, or what we call commonly the eclipse of the moon. What is an eclipse of the moon? The eclipse of the moon occurs when the earth comes in between the moon and the sun, thereby causing the earth to cast its shadow on the moon. Now, most of the time, we don't notice the eclipse of the moon or the lunar eclipse because it happens at night, or sometimes it happens during the day. So you find out that there's a shadow of the earth that completely covers the moon. We have two types of lunar eclipse. We have the total eclipse and the annular eclipse. With this, we come to the end of our lesson for today. What did we do today? We're able to look at the movements of the earth, two types of movement, the rotation and the revolution. And we're able to look at the effects of the movements of the earth. What we talked about for rotation, we talked about day and night. We talked about dawn and twilight. We talked about the apparent sunrise and sunset, among others. When we now came into revolution, we talked about seasons. It causes seasons. It causes the earth to experience a year. These are some of the things that we've experienced. We talked about why we have longer days and shorter nights, time differences. So these are what we've talked about today. However, before we go, I'd like to give you an assignment. I want you to practice and get back to me. These is a question for our assignment. A, with the aid of a diagram, describe the 4 positions of the earth during its revolution around the sun. With the aid of a diagram, describe the 4 positions of the earth during its revolution around the sun. B, explain why summers are usually warm and bright while winters are cold and dark in the Arctic region. Remember, the Arctic region is on the northern hemisphere. I take the B part again. Explain why summers are usually warm and bright while winters are cold and dark in the Arctic region. For further studies or to help you with your assignment, we have some references. Number 1, The Essential Geography for Senior Secondary Schools by O.A. Iwena. Number 2, The Certified Physical and Human Geography for Senior Secondary School by G.C. Leong et al., which is commonly called Goche Leong. And finally, you can check online by going on Wikipedia. I take the references again. Number 1, Essential Geography for Senior Secondary Schools by O.A. Iwena. Number 2, Certified Physical and Human Geography for Senior Secondary School by G.C. Leong et al., commonly called Goche Leong. And number 3, Wikipedia. Just go to your Google page on your phone and type in the questions you want. It will lead you to Wikipedia and you get the appropriate answer. You can reach me on my phone number 080-6226-1602. You can reach me through text messages, through WhatsApp, or you can call. Remember, reach me on 080-6226-1602. I remain your geography teacher, Wezi Jeremiah Akos. Remember, Corona is real. Stay home, stay safe, keep on learning. Thank you and bye-bye.